Good morning and welcome to this lecture of PD. Today we are going to discuss about some part of CNC machines, CNC machining, which is a part of automation from your syllabus. So you should know about CNC machines. Already most of you have some knowledge about CNC machines. I guess uh, every person amongst you have seen CNC machines at least once in their lifetime. Since CNC machines are available everywhere, if you have visited an industry, then you must have seen that in our institute in Polytechnic Wing, we have CNC machine. I think those who have completed their diploma, they must have seen that CNC machine. So basically, we are going to see about CNC machines, what is their purpose, how they are going to be used, and other things. So let me share the screen with you. Okay, can anyone just tell me, is it visible to you?
Yes, sir.
Okay, fine. So let's move on. So today we are going to discuss about CNC programming, part 1. Part 2 will be programming itself. So to start with, motivation and uses of CNC machine. Why we are using CNC machine? So they say that to manufacture complex curved geometries in two-dimensional or three-dimensional was extremely expensive by mechanical means. In earlier days, before the era of CNC machine, traditional machines were used like lathe machine, drilling machine, milling machine, shaping machine, etc. So the product design, the shape of the product was not so complicated at that time. No competition for no competition, at least we can say that very less competition for product development. So industries were not focusing on new product development or launching new product in the market, but due to the era of this automation and computerization of everything, the choices of customers has been improved, increased drastically. So to cope up with these choices, what companies have started, what industries have started, they have started introducing newer versions, newer type of products so that they can gain from it to achieve their ultimate goal of profit making. But what happened earlier when there was no CNC machine, no these kind of sophisticated technologies, they used to have simple products with not so geometrically curved or complex features. But as the time progressed, the geometrical features has to be changed in some sort. So to cope up with this, they required some machines or some technology that will help them. Okay, so the CNC machines have evolved from that. And now two-dimensional or three-dimensional machining is also possible by using CNC machines. Then the second requirement or second use or second motivation for using a CNC machine is the repeatable accuracy. If you compare a traditional machine with a CNC machine, what is the most important thing you will observe is the productivity. After that, you will go to know that accuracy of the manufacturing, which is repeatable. You must concentrate on this word repeatable accuracy. What is mean by repeatable accuracy? If a skilled person is working on a lathe machine, he may create a very accurate product. It is not like that. It is not going to make manufacture accurate product on a lathe machine. Yes, it is possible, but the person who is operating that machine, he must have that skill, and it's quite difficult to maintain that accuracy throughout the production. If you are doing a mass production, then absolutely you are time constrained. You have different targets to cope up. So in that case, there could be possibility of occurring an error in the manufacturing. So this will harm or reduce the accuracy. So repeatable accuracy is very important, which is found in CNC machines, because the operator is a machine or a computer system. So it will not have that human error part in that. Okay, so this is the important motivation. And unmanned machining operation. Unmanned machining operation means the human errors occurring due to the human perception views. Suppose a person is working on a lathe machine, he will be doing say 100 jobs in a shift of 8 hours. So he will have that target in mind. Okay, so what is the human tendency? Human tendency is that they will finish the work as early as possible so that they can get some relief from the work or the schedule from the schedule, right? So what will he do? He will try to complete the product as early as possible. So during these quick operations, or due to this anxiety of doing work faster, what will happen? He may lose the accuracy. He may impart some of the problems or errors in the products. So those products may get disqualified or rejected from the customer. So this was the possibility. But in case of CNC machine, what is happening? Unmanned machining operations are being carried out. The work of operator is just loading, unloading. In some cases, it is not required to load and unload also. Okay, in some cases, in some products like spring manufacturing, for each and every spring you don't have to load and unload the part, the wire in the CNC machine, because you have that roll of wire bundle over there and it goes throughout and it works. But whenever suppose there is a bar has to be trimmed or turned, or some sort of steps are to be created on a steel bar, so it is quite difficult with some machine to have this kind of technology that a long bar will be there and it will come forward and then machining will happen. So these kind of things will not take place because of the constraint of the technology. So basically what we are asking, we are trying to say that the machining operation is automatic. So this is the motivation and use of CNC machine. There are a lot of advantages since it is easier to program. Programming is easier. If you have the knowledge of programming, you can get a job for that. Easy storage of existing program, since the machine will have a computerized system integrated in itself, so it will have some library type system or function, or storage will be there, so you can just store the existing program and you can just retrieve it whenever it is required. Easy to change the program. On some machine you can go on some machine and just make a program while it is functioning already. You have instructed that machine to function and make some product, it is working already, but at the other end on the same machine you can just go on to write a new program also. Okay, so these are two types of machine, CNC machines, these are that are available: online programming and offline programming. These are the two types of CNC machines. Avoids human error, as we have discussed. safer to operate because human interaction, human intervention in the machine with the machine is less as compared to the traditional machines. So these are safer to operate. Complex geometry is produced as cheaply as possible. We have already discussed one. Usually generates closer tolerance than manual machines. Since we have discussed the accuracy part, so closer tolerance will be achieved by using these CNC machines. So these are the advantages. Okay, now see the vertical milling machine architecture. This kind of machine you might have seen in our workshop or in any industrial visit. So these are various parts of this vertical milling machine: column, slots, base, knees, workpiece is there, saddle is there, work table is there, head is there, tool is there. Okay, the movements up, down, to and fro, sideways. Okay, these are the movements that are shown here. This is called a vertical milling machine architecture. Now, this machine could be made as a CNC machine by using the computer interaction in that. Now, if you observe just go to the previous slide. If you observe these motions, if you are lying in the front of this machine here, you will see that this is the up and down movement, this is the left and right movement, and this is the to and fro movement, and this is the movement of tool. Okay, this workpiece uh, mounted on this saddle, workpiece mounted on this work table will move. Now these movements are very important. Got it? These movements are very important because these are the very basic functionalities to manufacture a product on a CNC machine. So that is why the CNC machines could be classified according to various things. So if you go for motion type based on motion, the CNC machine can be classified as point to point motion or continuous path motion. If you go for control loop, you will find that it is open loop and closed loop. We will discuss in brief later on. Just note down or you just go through this. What are the different classification is done for a CNC machine. The classification based on power supply can be electric type, or hydraulic type, or a pneumatic type, or a combination of these. It could be a combination. And on positioning system, we can say that incremental positioning system and absolute positioning systems. Okay, so this is how CNC machines are classified. Now, CNC principle. How does CNC machine work? So we have seen a vertical milling machine in previous part or previous slide example. So using a vertical mill machine center as an example, there are typically three linear axes of motion. Each is given an alphabetic designation or address. The machine table motion side to side means if you are on the front of that machine, the table movement is side to side. That could be called as x-axis. Table movement in and out is called as y-axis, while the head movement up and down is called as the z-axis. So these three axes are very much of importance. So that was a traditional milling machine. Now these three movements can be controlled by a servo mechanism as shown in this diagram. Okay, if you go through this diagram, you will get to know. See, there is a spindle head on which what we are mounting? We are mounting the tool. There is a machine table. Okay, and the machine table is connected with stepping motor X control. There is a control unit which controls this stepping motor direction. Another stepping motor is also connected in the 90 degree to this stepping motor. So you will get the Y control over here. Okay, and spindle speed control is given through this spindle head to this control unit, which is also connected with the stepping motor, and that is called as Z control, which is connected to the control unit. Now there is a tape reader. You can just obsolete or just neglect the tape reader since this is a NC machine system. So they have included the tape reader. We are not going into NC machine, we are discussing about CNC machines itself. Okay, so this is how each and every movement that we have discussed in earlier slide is going to be controlled by this control unit by using stepping motor, servo motor, or whatever the different types of mechanisms available for this. Okay, I hope you are understanding the CNC principle. Now there are coordinate systems. You can see absolute coordinate system and incremental coordinate system. So what is the basic difference in absolute coordinate system and incremental coordinate system? Let us start with absolute coordinate system. You can see here just we which type of graph we just draw on a graph paper like that. X y axis are given here. So if you go beyond this 0.0 point, you will get minus x and minus y. Same is here, drawn is here. So absolute coordinates are given like this. Suppose a point is there which is having x value of 1 and y value of 3. So we will get point C as 1, 3. Okay. Now, if you want to get a point A which is having coordinates like 3 and minus 2, so 3 and minus 2. So this is how we are just putting down the coordinates and which is called as absolute, means at that point only. This type of coordinate will consider the current position of the point to be discussed. While in incremental coordinate system, you have to go through making increments in the coordinates. Okay, so suppose in this case, in absolute coordinate system, let us start with A to B. Where is B? Okay, A to B point is there. So suppose we want to go from A to B. So in this case, you have to define the A point and B point as an absolute coordinate system. But in incremental coordinate system, you have to just find out the A, which will be the base of the coordinate system, which is going to be used as base, and the second point will be based on the prior one. This is called as incremental coordinate system. Absolute means at that point only, and incremental means it is going to be based on the previous part, and we are just trying to go to the next point by using this as a base point. So this is the basic difference between absolute coordinate system and incremental coordinate system. Okay. Just a minute. Okay. Now, how CNC machines work, how they work. Now, these CNC machines are programmed by using G and M code. These are the standard types of codes available for every type of machines. These are number values and coordinates. Each number or code is assigned to a particular operation. For a particular operation, for a particular machine, you will have a single code. It is typed in manually to the CAD by machine operator. As I have said that you have to go to the machine, you have to use the peripherals like a alphanumeric keyboard and type the program by using G and M codes, and you will get the complete program set for that particular product. So it will be having different operations in there. G and M codes are automatically generated by the computer software. Some cases you will have to just give a drawing to the machine, which is very highly sophisticated machine. So the drawing will be analyzed by the software and it will generate the G and M code program. By using G and M codes, it will automatically generate the program, and that program could be utilized for a working of the CNC machine. Now there are features of CNC machinery. The tool or material, any one of them, both of them can move. Tool can operate in 1 to 5 axis. So now nowadays we will be having 5 axis milling machine, 5 axis lathe machine. 5 axis machines are available. We in our syllabus we are restricted to 2-dimensional, 3-dimensional, 3 axis machines, but literally 5 axis machines are also available in the market. Larger machines will have machine control unit which manages the operations. Obviously, the machine, if machine will be having a computerized system, the machine will be having a computerized system, it must have a control unit for that. Movement is controlled by the motors, as we have seen in the milling machine condition in previous slide. The movements are being controlled by the actuators. The feedback is provided by the sensors, which are also, you can call it as a transducer. Tool magazines are used to change the tool. This is most important feature of a CNC machine. Since we are having an automatic machine, sometimes it is required to use 2 or more number of tools simultaneously, or you can say they could be used very rapidly. In that case, you have to arrange tools in the machine. They will have tool magazines and you will have the tools over there. The machine will automatically pick up the tool in some cases and go on machining the product as per the requirement. In some cases, which is not very sophisticated CNC machines, you have to use the manually you have to change the tools. But these are very rare right now, because all of them, almost 99% CNC machine will have this tool magazines, and automatic tool changer will be there. It is called as ATC. Okay, so I guess the time is up. So what we will do, we will stop here